amateur pinball repair technician. This 1978 Valley pinball machine. I've gone through it, and this had some interesting problems that you typically don't come across. I'm going to demonstrate them. I actually went through, fixed the entire machine, and then back unfixed it so that I could demonstrate that you can show it. Yeah. First thing we'll do is we'll kick it on. Whenever you get a machine, you want to turn it on and see what's going on. This one boots up just nice. Well, at least it did a week ago.
What did you just touch down?
If your game comes up, y'all know about the green dot, the green diode right here. If you flip it on and it comes up solid, I mean, that represents a lot of different problems. But on this particular machine, it's the J4 connector. Basically, it just needs to be cleaned. I've already went through and reflowed it. The actual contacts need to be, the pins actually need to be pulled out individually, sanded, and then every once in a while it won't boot to the 7th flash, and that's due to the 45 volts, not the CPU not seeing the 45 volts. Okay, so we got it up and running. When I got this machine, I mean, it was in horrible condition. I went ahead and replaced the driver board just so that I could get the game up and running. I didn't want to spend a lot of time messing with it. The CPU tested fine on my bench, so I put it in the game, fired it up, and it worked fine. As soon as you start a game on this thing, one thing you notice, there's no number digit right here. We'll fix that, we'll address that. Start the game, nothing. The first indication to that is that the J2 connector on the MPU, the ball usually kicks out every time. It doesn't matter if the game is in startup mode or if it always kicks, if it's in startup mode, it always kicks the ball out. So the first problem we had to solve was why wasn't it kicking the ball? Did you see that?
You just do it spontaneous.
It does it spontaneous. Now I've got one. Thank you.
Okay.
I'm going to tell you, that problem right there drove me crazy. And the reason it drove me crazy was because there's no, typically when I take a machine in, I don't take the back glass because I really don't want to be responsible for it. So the game kept doing that, and I was thinking, man, I've seen that problem before. And I remember that I had worked on a Paragon one time, and every time you started a game, it would instantly go to tilt. Well, on this particular game, you wouldn't know that unless you had the back glass. But right here, you can see that the game booted up, started, and went into tilt. So that immediately red flag, you want to check all of your tilt mechanisms. There's 3 of them on this game. There's one on the playfield. There's actually 4. There's a tilt bob, a little ball, one on the door, and one on the playfield. So as you can see, I've bent this one out of the way. There's one right here that I've bent out of the way. Well, I guess there's 5, including the tilt bob. There's one that has a little ball in the trough here, so you can't lift up on it. It's open. That one's open. This one's open. And the one on the door is open. So the first thing I think is, well, everything's open. Why is it tilting? Valley, in their infinite wisdom, thought they would put snubbers on all of the contacts. So every one of these little switches that has a diode on it has a either red or a 1 microfarad basically snubber. So if you look right here on this one, it's got one right here. It's got one on the tilt bob, and well, this one's been cut off already, and this one's been cut. So
can y'all say that okay?
Is a snubber a technical term? What, I mean, what,
it's a 0.1, I think it's 0.1 microfarad capacitor,
Okay.
Basically that goes across the
it's
switch.
like a little round wafer.
Yeah, the round wafers. So the first thing you want to do when you get a dialing machine that's causing you this headache is cut them all off. Because they are no good. You can replace them. I mean, the game will run without them with no problem. So the first thing I did was I started looking for them. Oh, this one doesn't have one on there. This one's got one on there, and this one's got one on there. So we'll just cut one of them. I like to always cut one and see where it's at, where the problem is, instead of just cutting them all. Boom. Okay, no more tilt. Did not go into tilt. So that snubber is shorted. So basically what happens is every time the game starts, it instantly shorts the ground and tells the MPU that it's tilted. Okay, so we got that fixed. This is a really interesting problem right here. So you're playing, you think, oh man, I got it all fixed up, I'm ready to go. Let's play some ball. Uh-oh.
Now it's like
What is this, a one-ball game? Then, I was like, well, wait a minute, how's that possible? Okay, so, get your meter out. Now, like I said in the beginning, the game will automatically kick the ball out every time. It doesn't need the switch right here to know that there's a ball in there. It will just continually kick it out until it reads on the first, until it's not there anymore. Okay? So, get your meter. First thing I suspect, always, are diodes. Set your meter to diode. Everybody got a meter?
Yes, sir.
Does everybody know what a meter is? The diode setting? Basically, it sends your voltage one direction, positive versus ohms where it read either way. So I want to check the switch. That's the first thing I want to do. Come over here. And basically, one way I should get a reading and one way I should not. Got 0.5 there. Infinity there. So the switch, the diode's good. The switch is open. Next thing to suspect is the wire to the CPU. So basically, you get an alligator clip. The wire you want is the colored wire. The solid wire is the common. So we grab that one, put our alligator clip on there. Careful not to short it out. I'm going to switch the meter to ohms. Get a little buzz. We're going to shut the game off. We're going to find the white with a red stripe right here. Did you see that? The wire just popped out.
The connector.
Okay? So basically, the connector is flawed. That's what happens over time is these heat up And because they're under tension, they'll crack and break off. Boom. We know the problem now. We get our little got some old pins right here. I always like the old ones. Silver's good too, it doesn't matter. Bigger fingers. Good. Got our crimps. Cutters. Cut this off.
You turn the
Crimp that on
the end of
there.
the wire and crimp to it, or what is?
What's that?
The pin just crimps on the end of the
Yeah,
wire?
you have to have a special tool. I mean, depends on what size you're using, but that's what I'm using. It's .011, I think.
And the bad part is,
.1.
if you find one like that, guess what the rest of them they're not gonna be
The
part of the whole.
whole line of.
Do the whole
Yeah, it's
line.
point- it's
And
point
flow of the whole line too.
Yeah.
I mean, unless you find one that's burnt, that's brown, that's just
Yep.
bad. But that's what's bad. If you find one bad one,
Do them all.
chances
Yeah,
are
exactly.
Oh, really?
If one's bad, they're probably all bad.
Yep.
But in this demonstration, we're just going to do one and see if we can keep going.
yeah.
Pop it in there. Slide it on.
It's kind of like if you're going to do it, might as well just go ahead and make sure you got everything.
Yeah, those little connectors, they don't take much. I mean, they're flimsy anyway. But that happens a lot. That's why John had a bunch of them ready to go. Because they-
It's good. Fixed. Yes, sir. Okay, so the next problem we want to address. Fortunately, customers are always picky and they want every light bulb to work. I don't know why. So basically, we want to hit the test mode. We want to look at all the lights, make sure they're working. All these are good. These are good. Good, good. We've got number 4 that's not working. Okay, now we need to see if it's in the NPU, the light board, or the play field. So the first thing we're going to do, with it in test mode, we're going to grab our trusty alligator clip. And the one we're looking for is right here, number 4. We're going to clip on to the positive. We're going to clip on to one that's working. Okay, now what that's going to tell us is if it's in the socket or if it's in the light board. If it works, it's in the light board. If it doesn't work, it's in the socket. Okay? If you really want to keep a Bally game, particular model that you really like, my suggestion is to change them all out. Okay, so on this case, we know that it's in the light board. Kill this. Well, the first thing we can do is we're going to kill it and we're going to test to see if it's in the wire. Wire color. The wire color is red-black. Don't want to mess with shells. Plastic dough should be all over. So we're going to clip our alligator clip on there. We're going to set our meter to ohms. What's nice about this is they'll sit right there on the pop bumper coils. They got nice brackets. Let's see the meter. And basically what we're doing is we're checking to make sure there's not a break in the wire. We're looking for black, red. Wrong one. So we know the wire's good. Okay? Then what we can do is we can push the if you have a schematic, which I don't have, you can look it up. Internet Pinball Database is a great resource for schematics. So we'll look up Playboy. Valley Playboy. Look for number 4, Grotto number 4, which is Q60. My phone just died. Okay, so we're going to pull this board off. I'm going to show you a way to test. See which one it is if you don't have a schematic, okay? We have an idea where it's at, right? I was actually working on Robert Clausen's KISS machine, and this test that I showed you actually tested out correct, working, and it actually ended up being one of these major chips on the board here. They have like 8 or 9 outputs on them. So we said Q60. So if you can get on this right here, we need to get the diode setting. We'll be able to get right here. Hold that right here. Okay, basically, we want to use the positive, the red, and we're going to test it against the other 2 leads of the 2N transistor, okay? One should be 0, infinity, and the other should read about 0.5. 0. Capacitors. Yeah, capacitors. 1,000 volt.
Yeah, there you go.
Sorry. It's not my meter. Okay, so we got infinity, and we got 0.6. That's perfect. That one's good. You can reverse check it, put the negative test it, and you should get like 1 point. You should get infinity on one side and 1 point something, 2.5. That's fine. And what you want to do is check each one of them against until you find the one that's bad. And you can do this for every one on the board, okay? So we said
Q6.
Q6. Let's check that. So we got the positive on there. Infinity. Okay? So we have a definite problem. You should be reading, so you can reverse it, double check. 2.511. That's too high. Infinity. And infinity. Okay? So Q60 is obviously bad. Fortunately for me, I have a spare board over here. Just pull some off. And I'll just check the one that's working. Let's see. Everybody got a HAAG?
Yeah, they
Gotta have
love it. It's so great.
Pig.
Yeah.
$50 all day long.
So are you pulling off a diode?
I'm pulling off a 2N. It's like 2N.
It's actually an SCR,
Exactly.
silicon controlled rectifiers. So very similar, somewhat similar to a transistor, but not quite a transistor.
It actually allows voltage to pass through it, not current. That's perfect.
Pinball machines have motherboards.
I'm sorry? Oh,
Pinball machines have motherboards.
yes, they do.
The heart of the pinball.
Yep.
The heart and soul. There we go, that's good.
What's that tool do?
It's
Not a solder, that's a
Solder
pig.
sucker.
What do you call it?
It's a pig. It's a
That-
vacuum
that
and a
tool
solder
sucks.
gun all in one. Yes. Very handy tool.
They make different size tips for it, so you can
Yeah,
get small,
great.
big,
That's
bam.
so great.
I mean, it basically pulls the chip out perfect. Every single time.
Yeah.
So you can let those
It's
traces.
still functioning like a soldering iron, you're just doing all the cleanup and stuff all at the same time.
Right. I mean, it works.
Soldering iron with vacuum.
Soldering iron with desoldering.
Solder something. Most of the high fluid ones have a separate. (60/40) acid resistant. This is organic, actually. It's environmental
Well,
friendly.
there's your tape. There's your tape, yeah.
So,
There's your blue tape, tape it in.
yeah, just set it on here. Double check. Good. Perfect. Good. Perfect. Throw it in the game. Number 4 is working. Piece of cake. Okay. So the next thing we want to test, it's hard to play the game. When you don't know what ball you're on. As you can see here, there's no ball count, okay? So the question is it in the display or is it in the CPU? Displays are always suspect first. Cold solder joints. This is high voltage, 190 volts. If you pull it off and you're touching this rail, trust me, you're not going to like it.
Oh, wow.
Yeah, this stays with them for a while.
Well, unfortunately for me, this has already been resoldered. I already did it. So what we need to do now is isolate the numeral that is out. Okay, so we know it's the last digit is ball count. So we can look right here. And my experience, it's always a resistor. It's never the transistor. Okay? So we'll put our meter on ohms. And we'll just go through and we'll test all the ones that are associated with this numeral, number 1. Start at the top. 1.5 is good. And if you're not sure what the value should be, just grab another one. Just grab one out of the game, or if you got a spare laying around, one that you know is working. Thought I had an extra one. Now Valley had several different styles, so make sure you get the right one that matches yours. In this case, we got a 2948-275, so it's the same one. And then you can actually put them side by side. Can you see that?
There's a flashlight. Anybody have a flashlight?
Let's lay it this way. I don't really need to see it, you guys need to see it.
There you go, Steve.
You got that far.
Takes a village.
Okay. We got 0 there.
Low in there.
So you're testing the pins on the...
Yes. I'm testing the resistors, okay? That's the first thing you want to check. After you check the pins, once all the pins have been reflowed and you still have a problem and you want to move to the resistors, then you want to move to the transistors. Yes, sir.
Is there a test you do with the meter to check the pins, or are you just looking at them to make sure they're all soldered correctly?
You can visually see when a pin has been heated to the point of cracking.
Hey,
Okay? Yes, sir.
does it have a ball in there?
A ball in the game? Yes, sir. How you think you're going to play pinball without a ball? Okay. So we're going to go through and test each one of these that are associated with the last digit. Okay, so we got 1.48 there. We got 1.48 there. 1.5. 1.5. 294. 297. That's close enough. Then we move down. 104. Nothing. Infinity. We have an open resistor right here. Double check. 104.6. Infinity. Okay? So we'll change that and see what happens. It definitely needs to change.
They'll send you a bill.
Quit presenting guys.
And when you pull the resistor out, you can actually see that it's been heated a little bit. I always like to pull it out of the circuit and double check. Sometimes it's another component in the actual board that's giving you the false read. And yes, this resistor is bad. So we'll put that up there. Since we have a good one here, we'll grab this one. R1.
Does that display that you're taking out of have other things wrong with it, or?
Actually, no, this one is a good one. I should be using this one right here. Actually, I will use this one. This one actually has problems with it. It's burned out. It's got burn in all in it. It's really, the glass is no good. But the board is still good. Let's just grab this one. Need bigger fingers. Alright, we got that in place. Save that. My fingers are too fat. Nothing a pair of needle nose pliers can do. We always want to double check our work. $105. Perfect. All right. So we'll throw it in there. See if we need another. See if there's any other problem.
The cause of the resistor again is just the heat over time.
It could be because it's got a burn mark in it. As you can see right here, it's going to pop up, boom. Fixed. Okay. What else? Anything else? We can go through and make sure that all the switches are working. I typically just take the glass off, play a game, start at the top, working, working, working.
What causes the fire in the display that you got going on right now? You got fire in that one you just fixed.
This one?
Yeah. See it?
That's a bad display, okay? So that's what caused the resistor to burn out in the first place. It's degassed.
So you would buy a whole new display for that?
You can buy a whole new display and desolder it from the board because you know the board's good now. And I think Marco has those. I don't know how much they are, $45.
They're getting pretty hard to come by.
Yeah, they're getting harder to come by. The LEDs are the way to go now.
They're kind of tough to solder into. The legs are, it's not a fun thing to swap.
What I found on swapping these out is if you use the legs like a fan, you start at one end and you fan them all in, they pop right in. And you slide them in, put some double stick of tape, and you're done, solder. Good. 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 Looks good. Okay, one bad switch right there. All good. One bad switch we'll take the same approach. We'll start with the switch and work our way back to the MPU.
So always assume it's out on the play field.
First.
Work your way
Yes.
back. Okay.
And the reason for that is because the playfield is what's getting all the bounce, all the work. It's the workhorse. The CPU is hardly the problem ever. Yeah, it's either connectors, or it's a switch, or it's a diode that's shorted or open, or even just broken off. Check this one out real quick. Just put our meter on diode. Oh yeah. Doesn't matter, it's like a switch. Oh, the diode's broken. See the diode's hanging right there? So basically it was just intermittently hanging. So it broke off. That's easy enough for us. Oh, we can test the diode and make sure it's good still.
You gotta resolder it back too.
Yeah, and then we're going to solder it right back on there. Positive side, you should get no reading. Infinite. And then you get a reading 0.5. Perfect.
So did the solder just break there on that switch?
Yeah, vibration. It's a common occurrence.
Yeah, you're more likely to have it snap off than to actually have a bad diode.
That's exactly right. Typically on a bad diode, it's usually open.
And there's very little current going through these diodes, so there's not any stress on them. So it's not like a power supply.
That's exactly right. Now your high voltage diodes for your displays on Valley is a different story. You probably wonder why I do that, because the vacuum will plug, and there's nothing worse than trying to suck some solder out and it's plugged. Just out of habit. Now the customer that owns this game is supposed to come pick it up today. I don't see him here, so. Free game. Free game?
way that switch works.
There you go. All right. I think that's about it as far as this particular machine is concerned. We tested all the switches. Everything's scoring correctly. Displays are nice and bright. This one needs to be replaced. Other problems that I had with this machine, when I turned the game on, here I'll demonstrate.
They're probably
If you look at the game, it has CPU controlled lighting, okay? And basically it's in a track mode. When I got this game, none of those lights were lighting. And the reason was in the power supply. The power supply has a 5-volt voltage regulator. F2, and it's BR1. So basically I had to change the bridge rectifier out. Once I changed the bridge rectifier out, the CPU lighting booted right up. Another problem I had with this was the 5101 chip had battery acid damage on it. And if you can see right here, I put a memory capacitor on there, cleaned up all the acid damage, resocketed the 5101 chip, and put a new one in there. And that's about it. This game's ready to go. Any questions? Any problems that you've seen in the past or currently that we could address?
I've got one right now that will reboot not only during gameplay, but if you just leave it on, it'll reboot itself. It's Bobby Orr power play. I've checked the voltage. Now I haven't checked it. I haven't caught it like had a meter on it when it does it. But I thought it was maybe the flipper voltage, you know, the voltage like dropping the voltage. But I haven't put a meter on it. But it'll actually, if you just leave it on, just like you've got it right there,
right,
it'll just reboot itself.
Typically, that's going to be your J4 connector.
Okay.
I would pull each one of those pins out on this connector right here.
Okay.
And I would clean them. The other place that's suspect is the driver board.
I think
J1, I believe it is.
I think I did the J4 already.
This one?
Yeah, I'm almost positive I did, but I didn't do anything on the driver board yet.
Well, okay. Well, all the voltage passes through the driver board before it gets to the CPU. Okay. So that's the first place you need to start. Okay. And any pins that are weak or won't hold any tension or are burnt looking, I just replace them. Valleys are notorious for having connector issues. Any other questions?
Yeah, the degassing issue where it's blowing something out, that's the same with like a DMV machine. So I have like a Maverick and
correct.
Now it's getting a little fade. I'm having power problems. There's like the noise is wonky and the motor starts sparking and all sorts of crazy stuff. That's pretty much all related to the gassing.
Say that again.
So when it's been on, like when you start it up, it's fine. When it's been on maybe like 10, 15 minutes, the sound starts crackling, only on certain sounds though. Like
no, that's going to be your soundboard.
Okay, but then if I wait like another like 15 minutes, like the motor has like a little flashlight bulb on thing and it starts crackling, flashing, and making all this noise. And that's only when the high voltage is on. So when I turn off the high voltage, like open the coin door, it stops. Close the coin door, it kicks back on. And if I turn it off and then turn it back on, it goes away and it's like it's heated up or something like that. I don't know.
I would definitely check all the connections.
Okay.
You might have a hot spot on one of the male connectors on the back side of the board.
I replaced the board and now it's like taking longer to happen, but it still happens.
What they're calling high voltage when you open the door is not the high voltage of the display. That's the solenoid high voltage.
Yeah, the motor flashing thing kind of goes away. You know what I mean? That turns off. And,
well, the motor's going to be under the high voltage, probably 35 volts. The flippers will be on that circuit.
This guy told me, and this other guy told me that it was just like the power board was like getting like blown because the DMD was sucking all the power. It was like.
And what game is this?
Maverick.
Maverick.
Yeah.
Data East, yeah, they have a separate power supply for that. I would definitely start with the power supply. You might need to replace the capacitor.
Right.
Yeah, well, I replaced the entire power supply with the rebuilt one I got from some online company or something like that.
And you've swapped it out and it still has the same issue?
But it takes longer for it to happen. So it used to happen in like 5 to 15 minutes. Now it's like, it took an hour yesterday. I left it on for an hour before it started happening.
Yeah, that's an individual problem that would have to be tracked down through the specific circuits that are involved. What you would want to look for is maybe a wire that's pinched and dragging the voltage down to the point where it heats up the power supply. Maybe that's why it took longer this time.
Like a thermostat thing, and I was shining on the within a couple minutes, and it was up to like 130 degrees. Some of those capacitor fields on,
That's not outrageously high.
Yeah, on the 5 volt 2N 3055, that's typical. They get pretty hot. That's why they got a big black heat sink on them. I'd have to see the game and I'd have to, trace it out. Just basically what I've done here is step by step and see what the problem
is. Well, I had
is.
another problem. It was like a value limiting game, like it was a Judge Dredd, and it would not get out of test mode. So it was just like, it was kind of like constantly the enter button was being pressed the entire time.
Did you check the switch to see if it was short?
Yeah, I actually cut the wires to the switch just to see if it would stop it. The little switch on the door. They ground, like I checked all the wires up to the board and they were all fine, pretty much. You know what I mean? Like checking to make sure there's continuity on the.
Well, then you would have a transistor on or the actual maybe a 6821 chip or something that's shorted right there in that circuit.
The same thing you did, pull it off and then check everything on
Exactly.
there.
And compare it to one that's on the board. See if you get the same reading.
Okay.
The only other step is to take a logic probe and put it on there and see if you're getting a high pulse the whole time. If that's the case, then you know it's shorted somewhere. You want to take over there?
We're about to run out of time. I was just going to go over a few small troubleshooting things you can do with this generation of Bally.
Hang on, we got to get you on camera here.
I don't know if you want that.
So where's the play button?
I think it's already gone. So, once again, I'm only talking about this generation of Bally. It's the way that the solenoids are all individually addressed by each one of these driver transistors. This is actually, I don't know, is this an Alltech?
Yes, it's an Alltech.
This is not quite how they look. Normally they have a TO220 package that comes out with a tab on it. What's handy about that is you can test all of your, if you have a solenoid that's out, you can, I'm going to start from underneath the board and then we'll go to the back box. Alright, so the way this all works is you have power roughly about 44 volts to all of the solenoids live all the time. So what that means is to activate a solenoid, you're just supplying a ground to that particular solenoid, one at a time. Incidentally, by the way, it only fires one solenoid at a time. No matter how much it's bouncing around, it's only doing one at a time. There's an exception to that, but I'm not even going to talk about that. So each one of these solenoids, if you have a bad solenoid, just as John was showing how to check the lamps, you can do the same thing with the solenoids. You got to figure out which one is power and which one isn't, but already. You can kind of first look and you'll see that there's kind of a daisy chain of the wires. Like the yellow, you can tell that this yellow wire is going to all the solenoids. So you immediately know that's your power. So,
the power is typically the solid wire. Ground is always the stripe.
And I'm sorry, I skipped over one step. What I did, what I've got here, and you can use whatever. I've just got a test lead. I'm clipping to the ground braid that's in the cabinet or the back box. The rail. Basically anything metal on the machine is ground. The braid that's on the play field is not. That is the 6.3 volts, either AC or DC, depending on whether it's a GI light or if it's a control light.
Put 50 volts to that and you'll burn it.
Don't clip onto that. Just find any good, spot. Okay, so what I have in my hand now is ground. So I can check each solenoid and see if the solenoid itself is bad or if it's the circuitry going to it. In a similar manner, just as John was showing earlier, you can also find out if there's a break in the wire between here and there. We don't have the same tabs on here. I imagine this. Okay, let me put this down so I can show you what I'm doing. Actually, John, can you just come around here so I don't have to sit the plate pulled out? You'll have all of your driver transistors on the solenoid board will have a tab coming off of it. All you have to do is touch each of these tabs and you test your solenoid. You are not testing the transistor itself. You are only testing the path from that to the solenoid. So that's not telling you if the but that at least lets you know the problem's here, versus down here. That trick, this ground trick also works on controlled lamps. Don't touch your GI lamps with it, but if you touch control lamp, you can immediately see if the socket, bulb, etc. is good. You can take the, I'm not going to do it. You can test it at the connector on the lamp board, but you have to know, you need to know what's what before you start. You need to look at your schematic and see what's what. Yeah. Anyway, so that's a way you can quickly test on these valleys, if your solenoid or your, where it is, where the problem is. Valleys of this era use basically they have a SCR for each light. There is no matrix for the lights, so that's pretty handy as far as so this doesn't apply to the don't do that. Don't do the light thing on the Williams game. It's not going to work. So anyway, that's kind of handy. Okay, so you've got the solenoids. Some of them are working, or let's say you start a game and the wrong ones. It's supposed to be doing one, but it's doing another. They're all messed up. Well, another thing that's kind of nice about these is the bus for the solenoids are the same as the sound. So if your sounds are working, you can kind of diagnose where the how can I describe this? So if the sounds are all working properly and the solenoids are not, it's going to be on the solenoid driver board. But if they're both incorrect, it's going to be back on the MPU board. So that may be a little bit confusing, but it's I don't know if anybody got that or not. That was
rough.
Yeah. Okay, let's see. What's something else I can? Oh, okay. So one of the first things that John talked about was the capacitor that's on some of these switches. Just for a little more info, the purpose of those, and as he said, the capacitors are not necessary. They are a pulse stretcher. You will see them a lot of times only on some switches and not on others. The target's common, something that's going to be hit really fast. So it will work without them, it's just not going to work properly. So, you probably want to put it back on if it had one on there. Okay, what's some, sorry, this is a bit impromptu. I'm trying to think of some other things that I could talk about on this.
Show that ground braid and the wing nut. A lot of times that's a
coming from the lower part of the cabinet up to the end. Sometimes it will not be connected.
Cameraman.
It's not focused.
There you go. Or you lower the playfield, you can see it easier.
So, you're right. Sometimes it will not be connected, but also a lot of times it's broken off. You'll see it attached up here, but when it goes down to the cabinet, it's supposed to be kind of loose going down, but it'll be broken off. Game will still work with that not connected, but you don't want to. It's essentially connecting the grounds between the head and the body.
Now check this out. On this particular machine, the playfield ground strap was not attached. Michelle was over there barefoot in the shop, and she was tapping on the switches, and she was actually activating other solenoids on the playfield.
Yeah.
So the ground strap is important.
Right, right. Yeah, once again, the game will still work, but it's a risk of, well, sometimes it won't work properly. Speaking of the switches, sometimes you'll see somebody has decided to take the diodes off the switches. That's bad. You gotta don't ever do that. It will work without the diode on there, but it's not going to work properly. What can happen is once so many switches are activated, it'll give the wrong code. I can draw it up on the thing, but it gets a bit techy. So just make sure you don't ever take those off for any reason.
Well, a common problem is when you activate one solenoid, two others on the same switch matrix will fire.
Same road.
Yeah, switch matrix problems can be really tough to diagnose. You have, they're
exactly.
So, before you start trying to fix it, start looking around. Just look around all over the place.
Look for the obvious.
The diodes sometimes they get smushed up against it, and they're shorting. You can usually catch it on a visual thing versus
especially ones that are close to the edge of the playfield.
Right, exactly. You'll have shooter lane ones in some games, and they'll get smashed on the side. That's pretty common. So just give it a good visual. If you've got crazy problems, you'll usually catch it that way instead of having to actually troubleshoot it.
Also, you have common power supply issues with these, with broken fuse holder clips, and usually crispy GI connector.
One problem that I came across, I think it was the Alltech replacement power supply board. Whenever it came from the factory, they had pressed the solenoid clips too far down through the trace, and it was a direct short. It took me forever to figure out what that problem was. I thought it was in the game. I replaced the power supply, and it ended up being the actual fuse clip was shorted to the board right there at the power supply. That was a tough problem.
Sometimes those fuse clips will be kind of loose too. You put your meter on it, and you've got continuity, but it's a little bit loose in there, and so it doesn't happen often, but it does happen. Any other questions?
One thing, Eric and I talked about that nipple on the back of those displays when you're working on them. The big ones don't have it, but those do.
Right, and a lot of times the holder, that's where when they seal up, when they run a vacuum on this thing, that's where they seal it off. Some displays will have like kind of a plastic backing with a hole, but
if you break that,
if you break it, you just throw it away. So there's nothing you can do at that point. Like any kind of vacuum tube, it's gone at that point.
Is that because the gas in the display has been put into a vacuum?
These are gas plasma. These are plasma displays, and
it's like a CRT.
So they put the gas in there and then put the nipple on there to seal it, and if you break that, you're done.
Yeah, I incorrectly said a vacuum. Yes, it is gas filled.
Filled and capped off.
Right.
They pay, and then I'd have called these guys a long time. I do.
I think I'm done. Unless there's more questions.
I just had one more. You said the sound, my problem, right? But the soundboard thing, just pull it off and just check it like you normally would. What I was saying was crackling, right?
Oh yeah, on the Maverick.
Yeah, you're like probably the sound.
Well,
so I can just double check that, just pull it off and just check it like you're.
Well, not so much the sound. I would go to the power supply first. Maverick. That's now 20 years old, and the electrolytic capacitors in them, they degrade over time. And a lot of times when you get noise through the sound, video game, pinball, whatever, the electrolytic capacitors in the power supply are becoming faulty.
I did replace that some of the product, maybe the power supply put in it that when I got to that again, right? I did do it. Like they were all replaced. So those big dogs, or things that look like.
Right.
What you can do is you can check your 5 volts and see if you have any AC voltage in it. And if you do, then you need to change the capacitors out for sure.
Is that the little black thing on the board? I guess you want to know that, right?
Is the capacitor?
Much about it.
Well, on your power supply board,
I got the schematics for it.
Yeah, but even if you get it, you still have a Maverick.
I trade.
Hey, Maverick's cool, man.
You traded for a middle
It's got a big display on it.
Which costs about $300 these days.
These are the capacitors that we're talking. You know, generally there's capacitors all over the place, but the really large ones are the filter capacitors, and that's basically what we're talking about. Now, if you get a conventional meter, even if you get a nice meter like a Fluke multimeter, you know, you can measure capacitance, and it may tell you good, but if you have an actual meter that's made for testing capacitance, this is what they call an LCR meter, and they have this thing called ESR, equivalent series resistance, which is an animal all to itself, which we won't get into, but the ESR goes up on them over time. And so even if you test it and you say, oh, this is, 200 microfarads, it's good, it's, just actually don't even test them. Just replace all the capacitors and what they call shotgun. Just replace them. Get it over with. They're cheap. It's easy to swap. Just do it.
We ain't hurt yourself.
You could have replaced it.
Exactly.
Exactly.
Yeah.
Exactly.
And when you test it, you don't know if it's right anyway, because a lot of times what Eric's saying is they fail.
Yeah.
But they'll give you a good reason.
This is going to be like 10 to 15,000 microfarad and probably 15 volts, 20 volts, because it's a 5-volt circuit. So it's not going to be a high voltage. It's going to have a lot of capacitance.
Make sure you install it the right way.
Yeah, they are. All your filter capacitors are polarized.
The cans.
They're you've got to usually a stripe. Used to be you had a stripe for the positive. Now it's a stripe for the negative. Just if you put it in backwards, there's no if. It will blow up. It will be loud. It will scare you to death. So make sure you put it in right the first time.
It gets hot and blows.
Yeah.
Now I know this doesn't pertain, but if you do jukeboxes and you don't read the schematic, sometimes the positive side of the capacitor goes to ground. It will blow up.
Yeah, when you have power supplies that have what they call negative rail, if you have negative voltages on your power supply,
You got a positive.
you will have, just as he said, if you just look at the, you can always tell ground on a PC board because it's everywhere. It's you know what's ground, and you will have positive going to of a capacitor going to ground sometimes. So anyway,
If you're doing monitors, be careful because they like to mislabel them too. Always look at how the cap's inserted.
On these power supply boards, when you take if you're going to work on replace the capacitors and such, just take a screwdriver and short the terminals out before you start doing anything. Once you get up to a size like this, you'll put it in your lap or something and it'll zap you. Just short.
I have a wooden bench that I do all my electrical on.
Yeah. Anything else?
Yeah, is the original owner showing up, or can we start the auction?
Well, we can do a quiz, and whoever gets the highest score can.
We're going to play this game again.
Well, I've actually got one of these that I bought a few years back. I don't know how much of it will be running. It's in a friend of mine's attic, so I was wanting to look at it just to
Sure, go ahead, look, check it out. You got any questions?
I haven't seen what one looks like.
It's on the game with the wolf whistle. You heard the wolf whistle?
Yeah. Well, I haven't really seen one, I don't think, hardly since back when it was out.
Thank you, gentlemen.